All right, we're going to pick up in Chapter 1, Section 3. We just finished talking about translating a function that is not the parent function. We have already moved, and then we are moving again. And we did the left, right, up, and down with translation. Now we're going to look at reflection. Reflection is in a mirror, and some line is going to act as your mirror. If you're reflecting in the x-axis is acting as your mirror. So it's kind of like mirror, mirror on the floor. If you're looking at the mirror on the floor, your reflection is reflected down below you. That's what's happening here. We're changing in the y direction. If the y was positive, when we reflect it in the x-axis, it is now negative and on the downside. In order to get that accomplished, we take the y and we negate it, which makes it the opposite of what it was. The f of x is the y. So in order to reflect in the x-axis, we're going to negate the f of x. That is contrasted with reflections in the y-axis. That's mirror, mirror on the wall. You're looking at the wall, it reflects left and right. It reflects horizontally. That's an x change. We're changing x's that were positive for x's that were negative, and vice versa. So we're going to negate the x. We're going to do that first, then work the problem. In contrast to reflection of the x-axis, we're going to work the problem, and then we're going to make it a negative, or change its sign. Okay? So let's look at an example. If we let f of x equal the absolute value of x plus 3 plus 1, we want to write a function called g, so we're going to change the name to g, whose graph is a reflection in the x-axis of the graph of f. Remember, if you flip back, in the x-axis, we're going to negate the whole equation. So for a, okay, good, got a good size. G of x is going to be the negative of f of x. And really I'm going to put that in parentheses because I'm going to negate the whole thing. So when I replace f of x with the absolute value of x plus 3 plus 1, I'm going to negative that whole thing. So g of x is equal to negative absolute value of x plus 3 minus 1. The negative goes times here, and the negative goes times there. Changes both the signs. It cannot go in the absolute value. And then I simplify anything, make sure my x is a positive x, which inside that absolute value it is. I don't have to eliminate anything. And that's all I can do. Now, if you think about logically what that is saying, if f of x was, if my k is up 1, and my h, remember it's opposite to get out, so my k is plus 1, my h, opposite to get out, is negative 3, so that's left, this is up, okay? I'd be left 3, up 1, and its absolute value, so it'd be a V shape. If we reflect it in the x-axis, this is the x-axis, it's going to reflect down the same distance away. So if I'm 1 away from the mirror, I'd be 1 away from the mirror, and I'm going to point this direction. I'm still at negative 3 for x. My h is still negative 3, but I've flipped over the x-axis, so now I'm down 1, and I'm pointing down. Remember, A tells you about points down if it's negative. Okay. Now let's look at B. I'm going to change color here to green so we can follow along. Write a function h whose graph is a reflection in the y-axis of the graph of x. Well, I forgot about y-axis, so I should go back and look at my notes. The graph in the reflection of y-axis, I'm going to negative just the x, the thing on the inside, and that makes sense. Outside the f of x area, outside the x area, is the y zone. Inside that x area, inside those parentheses, is the x zone. So I'm going to do f of negative x. I'm going to negative the x. I'm going to flip the x's to the other side of the y-axis. So when I replace this with the equation, we'll draw a better one than that. I'm going to do negative x plus 3 plus 1. Okay, see, I've replaced x with negative x. It used to be x up here. Now it's negative x in mine. Now, that's close to being finished. But I can't have that x be negative. So I've got to work on getting it out of there. So what I can do is I can factor a negative 1 out of the negative x plus 3, which gives me negative x minus 3 inside there. That's factoring. Factoring is like I have 2x plus 4, and I turn it into 2 times x plus 2. They both have a 2 in common, so I can pull the 2 out. Negative x and positive 3 have a negative in common. If I pull a negative away from x, it becomes x. If I pull a negative away from positive 3, it becomes negative 3. It would give me the same thing if I redistribute. Okay. Now, interesting property of absolute values is if you have an absolute value that has a multiply inside it, you can separate it into two different absolute values. So we can separate this into the absolute value of negative 1 times the absolute value of x minus 3 plus 1. The absolute value of negative 1 is 1, which when it's multiplying, I don't really have to write it because it just makes it the same thing. And now we don't have anything else to simplify. And if we think about this graphically, originally I was at 3 back and 1 up, and I pointed upwards. Now my h is positive 3 and my k is still plus 1. So now I'm 3 to the right and 1 up, and my a is positive, so I still point upwards. And I flipped over the y-axis. Okay. Now what I'd like for you to do is give each of these kinds a try. The first two problems, 1 and 2, are translation problems. So that's left, right, up, down, the h and the k part. The last two, 3 and 4, are reflection problems. So I'd like you to work each one of those, give it a pause, give all 4 a try, and then you can watch me work them. Okay, number 1. I'm making g of x by taking f of x and making it go up 5. Up is a plus, 5 is how far. Up is a k thing, so that happens on the outside of the x area, okay, and typically at the back end. So if I replace f of x with what it's worth for that problem, 3x plus 5, I look for simplifications in my solution. I can't simplify the right side anymore, so that's my thing. And that takes 3x and moves it up 5. Number 2. I need g of x to be f of x, but translated 4 units to the right. Right is positively. But what you have to remember is that inside with the x is a negative, and then that's where the h goes. Or inside, there's the x, and there's a negative, and that's where the h goes. So what we have to do is do f of x minus, and this is where we put the positive 4, which basically makes it f of x minus 4. Remember, it's opposite to get in, opposite to get out. If my h is a plus 4, when it goes in, it's got to be a minus 4, opposite to get in. So now instead of x inside the absolute value marks, I'm going to have x minus 4. So absolute value of x minus 4 minus 3. And then I look for simplifications. I can't simplify the absolute value. I can't subtract the 3 from the 4 because it's locked inside the absolute value, so I'm finished. Number 3. G of x is going to be a reflection in the x-axis of f of x. Well, I forgot already, so I'm going to move back. I negate the whole thing. So I'm going to do a negative of f of x. So my g of x equals negative times negative absolute value of x plus 2 minus 1. Take the negative inside and distribute. Negative times a negative makes a positive. Absolute value of x plus 2. It doesn't go inside the absolute value. Negative times a negative 1 makes positive 1. And there's no more to simplify. And number 4, the tricky one. But it's a line, so it's actually less tricky than if it was an absolute value or a quadratic. But my g of x is equal to, and I'm going to reflect in the y-axis. Oh, I forgot. Okay, let's go back and look. Okay, reflections in the y-axis. Oh, I negate the x. So I'm going to do f of negative x. So g of x equals 1/2 times negative x instead of positive x, because we're reflecting it, plus 1. Then do a simplification. I can actually do 1/2 times negative x. That gives me negative 1/2 x plus 1. No more to simplify. And that's how we can do translation or reflection, as long as we're doing just one of them and not combining them. It may get a little more complicated when we combine. We'll look at dilation, which is the shrink or the compress and the stretch.